Please welcome our final speaker of the day, Nathan Clouse, a technical architect. Today, he will be presenting Integrating with OData Deep Dive. Please stick around after Nathan's session for a live Q&A.
Thanks for attending DynamicsCon, and thanks to all of our sponsors for helping making this event possible. Here we're at the last session for the day, and I think the entire DynamicsCon conference. It's Integrating with OData, a deep dive. My name is Nathan Clouse. I'm a technical architect for Invista Corporation. I'm also a Microsoft Business Applications MVP. I have a blog where I talk about all sorts of AX-related things in 365 at atomicax.com, and you can find me on Twitter at Nathan Clouse AX. Here's what we're going to be talking about today. Just the who, what, when, where, and why of OData, what it's good for, what it isn't good for, other things to think about when considering OData versus some other integration strategy. We'll talk about extensions, authentication, and a wide variety of topics as it relates to performance, actions, and a specific construct called Postload. Before we get started, everything referenced in this presentation is available at these sources. So if you see any visuals or code or anything like that that we're going to be zipping through sort of quickly, it's all available here. So don't worry about trying to screenshot anything or anything like that. You can go to all of these links. It's all available. It's all open source and it's all free. So, first, what is OData? Here's just a, series of bullet points from Microsoft on what it is. They say it's the quote unquote best way to rest, but this is just another integration platform and option that comes with finance and operations. And for the scope of this conversation, we'll be talking about specifically using .NET Connected Services with OData, but there's a lot of different languages and platforms they can use to consume OData. So how are OData entities made? You just take a standard data entity, set public on it to yes, and that's really about it. Once you do that, the compiler will say that you have to fill out these additional properties. There's 2 more, but that's really it. That's how you turn a data entity into an OData entity. And Microsoft ships approximately 2,000 OData entities of their around, 4,000 data entities that they just give you. So there's a lot of stuff to take a look at if you need examples. One of the things that happens, so that there's some behind-the-scenes magic with OData entities, is when you make a data entity and you build it, there's a lot of code behind that gets generated that you don't really get to see, you don't get to interact with, it just generates it for you. If you want to take a look at that, that would be in whatever package you're in, /bin/generated XBP source. And you can review how your data entity works at sort of the lowest level. So you can see exactly what it's doing. So when you join this data source to that data source, what it's actually doing in the code. And this code is what's used for OData and DMF. So the next logical question, since I'm talking about OData, is what about dual write? So we won't be talking about dual write today. Dual write is a totally different integration option. There's a lot of use cases for that. I can already see one problem here. Oh, there we go. It is for integrating your finance and ops data over to the Dynamics 365 platform if you want to use a model-driven app. If that is your integration scenario, you want to use dual write. You don't want to, use OData. We'll be talking specifically about integrating third-party apps with finance and ops using OData. So first, before we even start talking about how to use OData, we want to make sure we're using it in an appropriate manner. So what's it good for? Basic CRUD operations on your declared data entities. So my list of customers, list of vendors, list of sales orders, and so on. In general, postings are not supported. If you want to use, have a posting, that would be some other integration option. And really, you want to think in terms of spreadsheets or list management. Again, customers and vendors lists and doing listing them or looking at them in some way or doing bulk updates. And if you want a real-world example of what OData would be good for, you can look at the Excel add-in. The Excel add-in from Microsoft uses OData to do all of your Excel uploads with journals and various other things. So what is OData not good for? Bulk extraction, you'd want to use the DMF with BYOD as an alternative, or exporting it to data lake when that becomes available. Posting a transaction, you want to use a custom service. You can use actions to do this, but we'll talk about that later. If you want to do anything with the Power Platform in any sense of the word, you want to use dual write. Next, if you want to extract data on a schedule, there's two frameworks for that. There's the batch data framework and the recurring integration framework. Or if you just want to react to something happening, an invoice posted, a customer was created, this, that, or the other thing, you'll want to use business events or Power Automate. So when working with OData, there are a few things to consider, mostly about the topology that you're on and where you're interacting with your OData. So as for instance, in a tier 1 or development environment, everything is all right there on that environment. So you have F&O right here on your development server, and you have SQL right next to it. That becomes important when you start talking about distance between your apps. So on your development environment, there's basically no distance. But when you take a look at a deployment that would happen in a tier 2 or above, which is a bit more distributed, there is some distance between those. On screen right now is the VM-based infrastructure for F&O. I couldn't find one for self-service environments. But again, you can see there is some distance between finance and operations and SQL Server. That may account for maybe 100 nanoseconds, but it's something to keep in mind. When talking about data entities versus OData entities, again, there's very little difference in terms of how you interact with them as a developer, but there is a lot of difference in how the system interacts with them. So in the diagram on the right, you can see that anything that's backed by DMF is an asynchronous operation. OData is a synchronous operation. And what that means is your OData entity has to do everything all in one to make sure you get the a positive outcome. Whereas DMF, it's sort of distributed and spread out. So in general, you have to optimize your data entities to be OData entities when you turn them into OData entities. That means enforcing more business rules. You have to be more stringent with your tests. So you'll want to test with DMF to make sure it works as a DMF data entity, with X++ and C# or some similar testing framework to confirm all your entry points basically give the same output. So if you make a sales order with 3 different ways, with DMF, X++, and C#, you get basically the same thing at the end of the test. And just as a quick call out, in case you didn't already know, you can use your data entities just like regular old record buffers. So on screen right now is an example of I have a data entity with a postload example on it. I just scope it as buffer, work with it like any old record buffer, and I don't do anything special. So I can use my data entities just like records, table-based records, and interact with them in the same way. Next is the order of operations that takes place when using a OData entity. This is an original work by an individual named Uwe Kruger. I wasn't able to track them down, but I just took what they did a few years ago, gave it a bit of an upgrade visually, and confirmed and made a few minor changes. But as you can see, when doing a create operation or a post, there's a lot of different things happening. With your data entity, I'm not going to just go through the list, but you can take a look at the level of interactions that are taking place and how it's grouped on data source or record or field. Similar with an update, still a lot going on, and we'll talk about what this means more in a little bit. So again, with a delete, a lot of different interactions at a lot of different levels with your data entity. Same with doing an action. One thing I want to call out here is when using an action on an instance, Postload executes twice. That's important. We'll talk about that in a little bit. And finally, just getting a read operation, doing a read or doing a get. We have just a single Postload. So next, when working with extensions with data entities, it's just like anything else at this point. Or earlier versions, there was a bit of heartburn around extending data entities, but now that story has improved a lot. So you can extend a data entity, add a data source, add a field. The only thing you manually have to do is copy that new field or new data source or whatever the case may be onto your staging table for DMF manually. It won't generate it for you, unfortunately. But same rules for extension basically exist when working with a data entity. So you can use chain of command, you can use event handlers. The only exception to this is using OData actions. If you add an OData action on an extension of a base data entity, you will not get a compiler error. It will not compile either. You'll not be able to consume that action. It just sort of goes off into limbo. Next, we'll talk about authentication very briefly. In order to authenticate to finance and ops, you have to use an Azure app registration. That gets tied to a specific user inside F&O, and that user gets tied to a legal entity. So real quick, you'd go into Azure, go to your app registrations. That would get you an application ID. You would have to give it specific permissions in order to access finance and ops data. Then you go into finance and ops in your Azure Active Directory application screen and copy and paste all those values in there, tie it to a user, which ties it to a legal entity. So next, we're going to talk about performance. And read performance is the biggest and most visible area of your performance, just because it's the first thing that happens and it always happens. So if you think about when you're doing an update operation or a delete operation, the first thing you have to do is confirm that whatever it is you're doing exists for you to do the second thing on. So I have to find something before I can update it, and I have to find something before I can delete it. So if you're looking at a workload of, let's say I just want to bulk update all my customers, set some custom field to blank. Well, first I have to find all my customers, then I have to update all my customers. So what appears to be a 100% update workload is actually a 50% read, 50% update workload. So read and performance becomes very critical when working with OData. And there's a few rules that I've put together, and I've run a bunch of tests to sort of confirm these rules. Fewer columns is faster. Fewer tables and joins is faster. The read-only attribute on a data source or an entity is for functionality only. It doesn't actually positively impact performance. Anything that you can do faster for one row, in general, translates to faster for 10 or more rows. So anything you can do as a set of 1, you can do as a set of 10 faster if you increase the performance of that set of 1. But also, as a call out, rows and sets behave differently. So sets are more performant than row operations. So, and we'll see that in some of our tests. So really quickly, I ran a bunch of tests. So I ran 100 tests to get 100 random sales orders from a various sort of just smattering of entities that I put together. And we're going to run through those. We're going to be focused just on the light blue line. That is get a random sales order. The dark blue is, get the same sales order over and over just to see if there's any performance difference. And there wasn't. So that was a bit of a surprise, but we'll be focusing just on the light blue line. So in the yellow box, we have out-of-the-box entities shipped by Microsoft. So these are sort of our baseline entities. There's nothing really special about them other than this is where we started in terms of performance, and this is what we're going to measure against. Next, in the red box on the left-hand side, I have a data entity that is a copy of sales order header v2, which is in the yellow box. And I set the read-only attribute on each data source in the data entity to be read-only and actually decreased performance. I can't explain why that is, but it's a measurable effect. Then in the red box, the one on the right-hand side, I just set the entire data entity to be read-only. And again, we had a negative impact on performance. So now on the right-hand side in the green box, the leftmost data entity in the green box is I took a copy of sales order header v2 and just started removing globalization stuff. So stuff that didn't apply to any of my legal entities. So like Thailand and Malaysia, there was some, I think Brazil stuff in there. Didn't apply to any of my legal entities. So I just ripped it out and removed the code that went along with it. And I got a net performance increase overall. Next, the next two entities, the two in the middle of the green box, are just entities placed on top of sales table. I just ran the wizard against sales table and made sure there were no extra data sources in there. So doing a find operation against those is much faster than out-of-the-box entities. And finally, the one on the farthest right, I took the sales order header v2 from Microsoft, deleted everything that wasn't related to sales table, and those are my performance numbers. So as I decrease the number of fields and decrease the amount of data sources, my performance, relative performance in aggregate, by quite a measurable amount. Next, we'll talk about subselects. So for those of you that don't know, when you build a data entity, the way that data entity gets represented in the database is with a view. And since it's a view, these views can contain subselects to other data sources. And Microsoft actually ships some that contain that contain subselects, but these can and more than likely will kill performance of your data entity just because of what it is you're trying to have it do. So this is an example that ships from Microsoft. Just other than looking really complicated, all it really does is, in your view, it does this. So you can see I've just got a case with a when and a bunch of conditions that translates one integer into another integer. That is a subselect. It's not ideal. It's not the worst thing in the world. SQL can do this relatively fast. If we have any SQL people in the audience, this is converting one integer to another. That SQL can do that relatively quickly. This is an example of what not to do. So first and foremost, on my where, I don't have a condition on partition. So all of my indexes contain partition. So that's something you'll want to do in there. But I'm doing a select on a set of 0.n. I'm putting that into a stuff operation, which is XML, which isn't exactly the most performant thing in the world. But more specifically, this is what's called a correlated subquery because its relative performance ties back to what it's subquerying on. So I don't know if this is going to be fast or slow. More than likely, it's going to be slow, but I just don't know. So that's one of the things that you really want to keep an eye out for in those, again, correlated subqueries. Next, we'll want to take a look at the select construct. What this allows you to do is select specific fields in your data entity to bring back. So then anything not in your select statement just gets ignored and it doesn't have to be packaged and sent back to the requesting application. In general, this will speed up set-based operations and slow down single record operations. And I've got some tests to show that. So again, we're running tests against a couple different environment types. We're going to focus on the dark blue line that is from a local app here where I am in Michigan, going to a tier 1 machine, which was in, I think, US East 2. I'm not sure exactly where that's located. I think it's somewhere around Chicago. But that would most represent if you have an on-premise application going to the cloud to get data for this, that, or the other thing. So first, we're doing a read 10. So we're getting a set of 10 records, and we're doing this 100 times. And then 372 is the average number, or the average time in milliseconds to do that. So this has no select. Next, we apply a select that has just the fields that you'd see in the sales order list page. And we see a performance improvement. We've done nothing to the data entity or how we're accessing it other than say, only get stuff I'm interested in. And we see our performance goes up. But next, we're doing a read on just a single operation with the same set of fields that we did in our last test, but I'm only getting one record. You can see our, in aggregate, that's an average of 286 milliseconds to complete that. But at my next test, I'm just doing a read 1. I'm getting everything related to that one record, and that is faster than doing, just getting the 5 or 6 fields using a select. So again, pay attention to what you're using. Are you working with sets or individuals? And use or not use select appropriately. Next is when you want to use or when you're doing filtering. This shouldn't be a surprise to anyone, but SQL has indexes and indexes work. But you have to keep in mind that if you're watching this and building data entities, the consumer of those data entities may be someone else who doesn't know how finance and ops works, or doesn't know the underlying data architecture. If you want to get sales orders, you should filter on sales order number. I mean, it seems like common sense to us, but the builder of the entity and the consumer of the entity may be two different people or departments and not know about the underlying architecture. So just be aware of where your indexes are. include those in handoff with how to consume the data entity. And also we're going to take a look at what happens when we start querying data entities without knowing what index we're using. Sort of very briefly, everything in the yellow box here, I'm querying one sales order header based on something that is not an index. And you can sort of see what my performance numbers are there. So this is after 100 tests getting one sales order. And you sort of see the performance is not great and it's sort of all over the place. And then here in the green box, I'm querying one record 100 times specifically on an index. And you can see my min and max values, the difference between those shrunk quite a bit, and overall my performance is better than stuff on the far left-hand side. So not that it's a surprise to anyone, but indexes work. We see sort of similar results when working with sets. Again, everything in the yellow box is I'm querying a set of 10, 100 times, measuring the performance, comparing that to using an index to do the same sort of workload. And when I'm using an index, surprise, it's faster. Next, I want to dig into specifically which indexes were more performant. This relates just to sales orders, but can be applied to a lot of different things. So on the screen right now is the results of running 100 tests, getting 100 sales orders on the sales order header V2 entity by using specific fields in the specific index notated along the bottom. And you can sort of see, my worst performing index is using customer and the created date time in the sales order. That doesn't make apparent sense to me, but it is repeatable and observable. Next is using the cost account ID index. Again, better than the last one, but not great. This was a bit of a surprise to me. So this value right here is based on just filling off of sales order number or sales ID, sales table.sales ID. And that is not our most performant, even though it is a unique index. Next is using sales type and sales ID. This sort of makes sense because type would be a subset of a sales ID. So next, this test was the wildcard. So this was me pretending like I don't know what indexes exist on the underlying data source. I'm just a C# developer that wants to get data from an OData endpoint. So I just gave it everything I had. And SQL actually did a pretty good job of figuring it out for me. So I didn't have to know that, sales order number was a unique primary key. I just said, here's everything I know. Please figure it out. And it figured it out better than the two previous tests, where I knew exactly what I was looking for. And finally, our best performing index, and this doesn't make apparent sense to me other than what it contains, is its cost index. So this is customer account number, purchase order form number, and I want to say sales type. But that is our best performing index on sales order headers when consuming a sales order header V2. So bit of a surprise, but could be based on my data set, could be based on a lot of things. But again, test with your data and be ready to learn and adjust from there. Next is the use of order by. Order by is a way to order your data before it's processed and sent to you, but that comes with some sort of negative performance implications because you're requesting the server that contains the data to also sort it. And we'll take a look at some tests that's not necessarily the best thing to do sometimes, especially when not using an index. You'll always want to have your order bys be on a specific known index. But just as a call out here for my tests, calculated fields and subselects did perform better than just plain old fields. But this could be based on my data set, which is Contoso. So always test with your data. So in the yellow box, we're doing an order by on a set of 10 records. And the field we're ordering by is not part of an index. You can see our relative performance values are not great, but they're okay. You can also see we have a fair amount of variability, the difference between the orange and the blue line. Next, we're in the red box, we're ordering by on calculated fields. So in this instance, these are subselects. A tiny bit better than just plain old fields. But finally, in the green box, we're ordering on specific indexes, and you can see the order by ascending is the most performant of our order by operations. You can order by descending or ascending, and if you need to do an order by, do an order by ascending on a declared index to get the most performance. The other alternative is to get all of your data, and then once you've got all of your data in your requesting app, sort it there. That if you're using C#, that's something that can happen very, very fast. These are numbers from a dev machine. This is what it looks like when using a UAT machine. So you can sort of see our amount of variability goes up quite a bit, but same sort of results as last time. Yellow is not on an index. Red is on a calculated field, but by far and away, our best performers are doing an order by on an index. Next is using multithreading. So this was just sort of something fun I did just to see if I could break it. But when you ask your AOS to do more work, that means more loading, longer loading times. This is largely a CPU constraint problem. If you're really interested in that, more CPU means more speed, but request processing scales time are scaled linearly with thread count. So it's good to see that IIS is doing this job. But the major call out here is that development, UAT, and prod are different. And lastly, don't do this. So we'll talk about, here's an example of some tests that I ran. This is against a local VHD. So this is running on my computer here sitting next to me. I took a VM with 6 cores and ran a series of tests. The first one being with 1 thread, fetching 100 random sales orders. Next was 10 threads, fetching 100 random sales orders, then 25 threads, and so on and so forth. You can see as I gave the server more work, the amount of time it took to handle and process that request goes up. That makes sense. But when I doubled the amount of cores on that machine, you can see the amount of time it took, especially when we get near 250 and 500 thread count, improves quite a bit. But, you don't want to do this. You don't have specific control over hardware in your UAT and prod environments. And also, here's what it looks like from prod. So, I'm sorry, not prod, UAT. Our times are in general higher, so we're going from a machine right next to me into the cloud, so that accounts for some of it. But also, you'll notice my graph stops at 100. Once you start using more than 100 threads, I started getting 503 errors. So there's some throttling mechanism that exists in UAT and more than likely prod that does not exist in dev. So again, they're going to be different. You're going to want to test in both. Next, we'll want to talk about expand. That lets you expand from one data source to another data source on your data entity if there's a declared relationship. And in general, these are slower to perform on a tier 1 and are faster on a tier 2, and we'll dive into that. So here I've got my sales order line V2 entity. So this is just sales order lines. It's got a declared relationship to sales order header V2. So in a development environment, I ran 3 tests of read expanded, so that where I got a sales order line with its sales order header. Read combined, where I have 2 requests, one to get my line, one to get my header. And then my last one was just get my sales order line. So you can see on the left-hand side, my read expanded in a development environment was my worst performer in aggregate. And my best performer was just getting my sales order line with a read combined of 2 different operations in the middle. So that sort of makes sense because with a read expanded, I'm basically fetching data from 2 data sources. However, when I go into a UAT environment, that property or whatever it is I'm observing in that dev environment doesn't actually apply. So same set of tests, and you can see my best performer is still just get my sales order line. My second best performer by a very narrow margin is read expanded, which is get my sales order line and the header for that line. So just sort of interesting. Again, stuff will act differently between the topologies. So test in both and make sure whatever it is you're observing holds true in both. Next, we're going to talk about pagination. So OData will come in 10,000 count pages. And if you want to loop through those, there's 2 basic methods. There's the skip and take method or the continuation method. Skip and take is, you take X while skipping Y, or in general, take 10,000, skip 10,000, or take 10,000, skip 100,000. That allows you to manually define your offsets and get, specific pages in your entire list of pages. Next is continuation. So each page will have a next link if there is a next page, and this just follows that link. So here is an example. So I use sales order lines from Contoso data. There's approximately 200,000 of those, and I just loop through all of them just to see how long it would take. We want to focus on the graph on the right-hand side. But using the read all pages query, or that's using the continuation method, it took 182 minutes to get all 200,000 records. But using skip and take, that took 217 minutes. So both of those numbers are relatively terrible, but you can see that the continuation method is faster, and that's because it's stateful. So just really quickly, how to do a skip and take. It's this block of code right here. And for this slide, I actually just noticed there is a minor error. So if you've noticed what that error is, please leave it in the chat. And just as a quick call out, if you want to get the number of records in a data entity, the fastest way to do it is this. So you do data entity.take0, which means take nothing, but then get the count for that. That's the equivalent of doing, select count one from table name. It's the fastest way to get the count for a data entity. Next, we're going to talk about how to do a continuation. So here we're getting a response from a data entity that has a particular query on it. This is running wide open on purpose. In that response, I check to see if it has a next link, and if it does, go ahead and get that next page. And I'm going to loop through until I no longer have that next link. So that means I'm going to continue looping through pages until I get to a page that doesn't have that next link, which represents I no longer have a next page. So really quick, want to talk about cross-company. The user that you're integrating with is tied to a specific legal entity or company, and your OData app will be tied to an authentication ID that's tied to a user. So in general, your authentication will tie you to a specific company. If that's not a behavior you specifically want, you can use the cross-company feature. So you just, in your query, say cross-company equals true, and that will get rid of the default filter for your integrating user to only fetch records from the legal entity that it currently belongs to. So when talking about read performance, we want to take a look at keeping our entity simple. So Microsoft delivers a lot of entities out of the box. And if they are not performing to your standards or what you need them to do, you can copy and paste. And I call it chop out what you don't need. But again, this is based on your needs. This has two major benefits because you have complete control. But you also have to reconcile all the changes that come out with every version from Microsoft, which can be a bit onerous. So when we're looking at a entity that's delivered from Microsoft, this is sales order header v2. All of the green arrows here represent globalization data sources, which may or may not apply to your organization. Next, we've got the light blue arrows, which point to views or data entities, which are represented as views, which are typically where you see your biggest performance issue. And then the dark blue arrow points to functionality that in my demo data, there were no records for. So again, you have to evaluate what it is that you're trying to do and deliver to that requirement. Next, we have I call these compound entities. These have lots of data sources, lots of code, and in general, the amount of data you give these things is an indicator of how they'll perform. So you give more data, they take longer to persist that data. And we have, I've run a few tests here. This is the result of what I call a maximum workload, where I give it a ton of different data to save. It's the same basic entity, but I'm just giving it more data, and that takes longer than to do just what I call a minimum workload, which is just enough to create a sales order. This is in a developer environment, so that's what we want to look at here. So our numbers are going to be a little bit better than UAT. But when looking at a minimum workload, it's sort of this. I'm doing the bare minimum to create a sales order, which isn't much. And when looking at a maximum workload, I'm creating my entity and then filling in a bunch of fields. And when we're doing that, you can sort of see the difference between the amount of time it takes. So in a UAT environment with that same workload, it takes about 2.2 seconds to create a sales order with all of my attributes in my quote unquote maximum workload scenario, and 0.9 seconds or 909 milliseconds to do just the bare minimum. So these are just performance numbers to keep in mind. Next, when we're talking about performance with an insert workload, again, you want to keep your entity simple with very little code and only do what's required. And again, performance scales the amount of data being persisted. So here I took the sales order header v2 entity, copied it, removed everything that wasn't sales table, and ran some basic tests against it. I created 100 sales orders in my maximum minimum workload scenarios. And you can see with my maximum workload, it only took on average 194 milliseconds, and with a minimum 155. So the difference between the two is much smaller when I have a simpler entity, which is good to see. But again, this is what my minimum workload looks like. Again, I'm just making a sales order with nothing on it. And this is my maximum workload. Since I only have sales table to work with, I wasn't able to use as many attributes. But again, you can sort of see on the left-hand side, this number from Microsoft is our best case scenario, 254 milliseconds, with a complex entity or a compound entity. And then on the right-hand side, with a much simpler entity, even our worst performing scenario performed better than Microsoft's best performing scenario. So again, keep in mind and develop and deliver to your requirements. Next, we're going to talk about update performance. It's basically the same as insert performance. You'll want to keep stuff with as few fields and data sources as possible. And when you're ripping stuff out, make sure you keep business logic there as it makes sense. But again, on the left-hand side, we have our compound entity from Microsoft, which we can see our performance numbers relative to running 100 tests. And on the right-hand side, we have a simple data entity that is just a copy of sales order header with everything not sales table in it removed. But you can see just how our performance number scales, and this is against the same environment type, same workload, and this is all down to just the data entity being more simple. So again, test with your data and your workload and your scenarios. So next, we're going to talk about delete performance. This is very similar to insert or update performance, but this is a bit of a unique case because it is possible to just scope on your primary key for a delete operation and then go ahead and delete it. You don't need to know about all the other fields to delete something. You just need to confirm, is it there? Okay, delete it. So I created this concept of a single entity, and this is what that would look like. I copied the sales order header v2 entity from Microsoft, stripped out everything that wasn't a sales order number, kept the key on it and this range, and then ran a series of tests. So here I'm creating the sales order. Here I'm deleting it. And these are the output of those tests. So the Microsoft entity to do a delete operation on average takes about 643 milliseconds in a developer environment. With a simplified entity, it takes 231. And then with our single entity, which can only do a delete operation, we see about 40 millisecond on average performance increase. So next, we're going to talk about actions really quick. Actions are these really cool things you can tack on to OData entities to have X++ code run as part of a request. So you can add on really anything that you would want to do in X++. You can get the customer's last sales order date on the sales customer v3 entity. You can also have these update or create data, and you can put these on a specific record or a collection of records. So very versatile, very, very easy to use. But again, these are only on custom data entities. These cannot be applied on extensions. Lastly, I want to talk about Postload. So Postload is a really cool feature that the kernel has that allows you to execute code when a record is loaded on tables, views, data entities, and maps. You'll most commonly see this now on a data entity, and you can do whatever you want you would normally do with X++ in here. But just as a call out, when we look back to our execution hierarchy, Postload gets called several times in a single operation for a data entity. So whatever you add in Postload may execute 1 to 3 times depending on your workload. And if whatever you put in Postload slows things down, you're going to have to pay the performance toll for that. So here's an example of a Postload. So I've added a lot of unmapped fields. You'll notice above the arrow, I have to provide sentinel values or default values for my fields, because depending on whatever it is I'm doing with this, I don't know if I have a record or not. If I do have a record, then I put actual values in those fields. But again, depending on what it is I'm doing, I don't know, so I have to make my Postload sort of safe for, do I have a record or not? So, I won't read the recap slide to you, but these are the major takeaways. But really, the most important thing is to build your entities, measure your entities, and learn from those measurements. And sort of go right back to build and continue that cycle of making your entities better to fit your need of your integrating third-party app or whatever the case may be. So thank you again for attending. I also have my contact info here. If you don't want to post in chat and want to ask me privately, that's how you can get a hold of me. Thank you.
I don't see you, though. There you are, Nathan.
So, hello.
Hey.
So, did we have any questions from chat that weren't answered?
I think you got the ones from Faze and Mike. I have a question for you, Nathan.
Sure.
I see that you have a green screen behind you, but you have chosen not to use it. Why?
I couldn't get my new camera software set up in time for this. So I've got a green screen. You can put whatever you want behind me. So maybe I'm running away from a T-Rex, who knows? So I think we had a question from Faze.
One at the very beginning.
I think it was, Faze is saying he's a functional person, recently working with a third-party company to push-pull via OData, so where I can test for these OData entities myself. So you can, I'm going to sort of interpret the question a little bit. You can use the data management framework to test with some of your data entities, but that's not necessarily going to be the same exact test that you would run with OData. OData is a different connection point, a different way to interface with an entity. Not all data entities that are present in data management will be available for OData consumption. Last time I checked, there was 3,000-ish entities, but only 1,800 were OData enabled. But that would be a good way to validate the data that you would be getting in and out once you have identified that your data, that your data entity is an OData entity. And then I think there was a second part. Let me read that real quick. So yes, so the question was, when you're testing with OData versus using the DMF, is that testing different? Yes. So in my presentation, I had some slides specifically that showed just the order of execution as it related to OData. On my blog, I've got an extended article where I talk about the difference between how OData executes, which is synchronous, and DMF, how that executes, which is asynchronous. So there are some different steps that stuff goes through for the DMF that doesn't happen via OData. But you would get very similar results, but not necessarily the same exact results. Excuse me. So Frank is asking, do your clients have a good grasp around this OData stuff, or in reality, are partners the key for clients to benefit here? It's sort of both. So when we talk about available integration patterns from F&O, they hear about OData. They don't necessarily know what it is. They just know that there's data entities available and there's ways to consume and push data in and out. So there's just, it's sort of known about, but not really known to a great detail. The simple case that I always use is, the Excel add-in. Whatever you can do with that, you can do with OData, because it's the Excel add-in is using OData. So that's sort of the example that I use. No, so Florian is asking about if I ran into 429 codes for throttle-based with priority-based throttling. So no, I set my throttling to be basically turned off by setting, I had a default throttling group and set it to high. And I was largely using either a UAT environment that didn't have anyone in it at the time, or a developer environment. So the likelihood I would hit a 429 is relatively low, just because I was doing this late at night when no users were in there. But that's what Florian is asking about is a new feature that just rolled out a month or two ago. So if you're consuming too many resources with your OData calls, you'll get a 429, which is a specific HTTP code to say, hey, you've been throttled, dial it down a bit, or you're going to have to wait for your process to, or for your request to process.
While we wait for some more questions to come in, I haven't been in the AX space for a while, so this OData is new to me, at least. How does this differ from, say, AIF or I've heard about connected services?
Excellent question, Scott.
Stop it.
So the AIF is a construct that was for 2012, which is a WCF based service framework around SOAP. That is no longer there in F&O. Well, I guess let me rephrase. It's there. Microsoft has removed a lot of functionality from it. It'll still work, but Microsoft sort of discourages its use, but it's still there. But that's just for the WCF portion of it. AIF is totally gone. The sort of the replacement has been OData, which is REST. So you can have, you can create your data entities and make them OData enabled, and then you get a lot of value from that. So you're sort of building your services or just interfaces that can push and pull data in and out without having to go in X++, make like a WCF service that handles all that stuff. And then you have to deal with all the WCF stuff that sort of comes along with it. And then for connected services, in my examples, I just use connected services because I actually don't know the syntax of how to query RESTful endpoints very well. So I just pointed connected services at where all my metadata was, and it made a bunch of wrapper classes for me based on all the stuff I had available, just so that I could get an easy to use catalog. So I could say, get me all my sales orders, get me all my purchase orders, that sort of thing, without necessarily knowing specifically that endpoint's name. It just sort of enumerated it for me. If I want to throw in some where clauses and enumerate some of my fields, it just makes it easy to work with.
Nice. And that's widely available, the connected services? Yeah,
so it's available for Microsoft. And there's a couple different flavors. There's the Microsoft version. There's a version that's based on that called Unchase, which I was going to take a look at. But yeah, it's all it does is you point it at a set of metadata, and it will generate a bunch of your wrappers for you. So you don't necessarily have to know all of your interfaces or all your integration points or anything like that. You can just say, here's an endpoint with metadata, generate all my clients for me, and then I can consume those clients however I see fit.
Nice. Sounds like a soap WSDL, so to speak.
Yeah, so very, very similar construct, except it's REST rather than SOAP.
Right. That sounds pretty useful. Does that generate all your request and response objects as well?
Mm-hmm.
Oh, man.
Yep, so you can interface with collections, you can interface with individual records, you can ask a collection for a set based on where you can do. I sort of covered all these, and I have code samples out on my GitHub to how to do all these different things and interface with, I want to do like if I were in SQL, I'd say, select top 10 star from table. You can do this very similar thing in OData with, I have to say, select this many records, select top 10 where some condition, and then I get the same sort of data set back that I was if I were working with SQL, but it's all wrapped. And then there's security applied on top of that from the user you're interfacing with. So I mean, there's just a lot of value because they already exist, and you don't have to write custom services to, let's say, make a sales order, because you've already got, I think, 5 different sales order endpoints to choose from already.
I think Florian is the eagle eye that spotted your little bug in your pagination example.
Yep. So behind the scenes, Scott, who doesn't do AX anymore, so he's moved on to C#. So spotted it almost immediately. So
plus pointing you out as being wrong any chance I get.
Yes, I mean, we've been going on I've known Scott for 11 years, and he always enjoys finding things that I do wrong.
How egregious does one have to be to trigger the 429? Do you have to go out of your way to be a good actor in situations where you're consuming these, or is it something where you kind of have to be knowingly doing something pretty abrasive to trigger that situation?
The answer is yes. So
yeah, sure.
Hold on. Yeah. So there's 3 different levels of throttling that you can set up, and it's based on throttling for the entire system, the entire health of the overall.
Is it multi-tenant at that point?
In terms of AD tenants?
Share, I guess so. Like I said, I've been out of the AX space for a little bit, but my understanding is like Nav, for example, is now multi-tenant in as much that my assumption is that a few customers may be using shared hosting on the same box, and you could run into usage caps relative to other tenants also utilizing. No, okay, all right.
No, so there's 2 styles of infrastructure, and we're straying a little bit, but one is VM based, which has largely gone away, and one is Azure Service Fabric based, which are microservices running in an Azure Service Fabric instance. There's multiple instances, so you have multiple AOSs, and these requests are being sort of round robined against all of those available AOSs, but the throttling takes into account the overall load of the system. So let's say on the OData side, you're being a good actor, but on the flip side, let's say someone is just holding down the F5 key, running the inventory on hand report infinitely, and that's consuming all sorts of SQL resources. I don't know specifically if you can do that, but I remember that happening in AX 2009 when it was in its own window. So you can still be a good actor and get throttled if there's something else going on, because it takes into account performance of the entire solution, not just what it is that you're doing. That having been said, OData historically has probably been the biggest offenders because it's all been on, at least in the production instance, it's all Microsoft's hardware, and it scales based on demand. And you can ask for more based on, hey, I'm utilizing a lot of this stuff. But part of that is if you've got infinite resources and infinite resources available, you don't have to tune your code. You can say, all right, I'm going to select 100,000 records just to get one. And now Microsoft's sort of clamping down on it. That's the throttling that Florian mentioned.
Sounds like a case for the old thread.sleep.
Well, yeah. I mean, there's if you're looking for large quantities of data, there are other options available. But for, let's say you've got, like some e-com website that accepts orders and you just want to send orders over in real time or batch them up every 10 minutes, whatever the case is. OData is a good example for that, as long as you're less than 10,000 orders per batch or per instance. If there's more, there's other integration technologies available.
Right, maybe some sort of like message bus or something.
Yeah, so then your website's pushing on there, and then there's a thread that's constantly taken off that stack, or off the queue. So any other questions? And Florian, don't try the F5 trick. But try it on a developer environment. Don't do it in production, please. Well, Scott, did you have any other questions?
I do not, Nathan.
Okay.
Nice presentation.
Thanks. So I think we'll, I guess we can chit chat for a minute or two, and then we'll probably call it a day. So everyone, thanks for attending DynamicsCon. This is the last presentation, so hopefully saving the best for last. If not,
you tried.
Yeah. So, all right, I think we're wrapping up in chat. So thanks again, everyone.
Take care.
Thanks.